Thank you for everyone, ladies and gentlemen, for joining us this evening. Daniel Messina from NXTGEN Technologies to the forum tonight. He's going to share with us some of his insights. Daniel and I actually worked together in previous lives and have known each other for a number of years now. So it was nice to reconnect and invite him in. And what Dan will be talking about tonight is his passion as a robotics engineer. He actually started as a mechanical engineering some 10 years ago, dabbling into robotic design for smart prosthetics, and later transitioned into building design and digital engineering. Later on in 2017, he found opportunities to enhance current industry workflows by introducing robotic technology into the building industry. And he also became one of Engineers Australia's most innovative engineers in 2018. And that was quite a significant achievement. I remember that we were working together at the time.
Yeah.
Daniel continued to facilitate growth and innovation in implementing robotic technology, and then went on to form his own business, NXTGEN Industries, in 2019, where he's been the founder and managing director of that business since that time. And that company provides industrial robotic design and build services. He can also provide robots as a service. We talk about security as a service a lot with our clients, but Daniel's familiar with a similar concept called robots as a service, and he'll touch on that in our presentation. And also can provide perception and vision systems, as well as robotic consulting services. So without further ado, I'd like to hand over to Daniel, and he's going to run us through the presentation this evening.
Thanks, Shane, for the intro. I'm very excited to be sharing some of my insights today, especially around robotic tech and how it can potentially impact the security industry. So I'll dive through a bit of a summary of what I'll be sharing today. So I'll give you a bit of a background of about my business, NXTGEN Industries, who we are, the industries that we serve, some of our skills and services. And then I'll dive into briefly just some of the projects that we've worked on, and this will give you a bit of an insight into, I guess, some existing technology, existing capabilities. And that's also going to be pointed out in some of our solutions. So we'll talk about our robotics, autonomous robot, and also some of our inspection and monitoring solutions as well. And then lastly, we'll be diving into, I guess, the security-centered portion of the piece, where we're going to be looking at existing solutions out in the market, some of the robotic applications, and how we can successfully harness robots in the security industry. And then we can go through some questions after that. Okay. So,
and I should mention, Dan, just before we get started, that I've just mentioned in the chat box, for any questions that do pop up, just throw them in the chat box, and then we can run through those at the very end.
Awesome. So a little bit about NXTGEN Industries. We're an innovative startup, and we specialize in robotics and data intelligence. We're essentially driven to enable digital technology and robotic adoption through various industries. Now, our key differentiator when compared to other robotic companies is that we're not actually focused on developing and selling standalone robotic solutions. What we're actually focused on doing is working with businesses within various industries, and then identifying where robotic tech can provide value. Then we work with those businesses, and we actually develop scalable solutions through partnerships. And this way, it becomes fit for specific industry implementations, and also making use of our technology as well, which also facilitates rapid adoption and implementation. So, as I mentioned earlier, we do work across many different industries. We like to consider ourselves as industry agnostic. And the reason why is in all of the industries that we serve, we always find that the requirements that industry is looking at for robotic tech is often more is often very similar. They're looking for that mobile autonomy, the ability to, provide eyes and ears, without having to need people there. So, and delivering insights. So we do serve a lot of these industries, and I know I don't have the security industry up on this slide, but I also feel that there are going to be some commonalities and problems that we'll discuss later on that are also shared amongst some of these industries that we've served in the past. So when diving into, I guess, the skill sets that we have in our business and what's required behind robotic development, we cater around mechanical, electrical, control systems, and software engineering. Now, all of these skills are required to deliver the variety of services. So Shane mentioned a couple earlier. We do offer those industrial robotic design and build services, robotics as a service, and I'll talk about this a little bit later on. But it's becoming really, really valuable where some businesses can't justify purchasing robots up front, and whereas they implement them as a service. So it becomes an operational expense rather than capital expense. So where we have robots available to perform tasks, we offer these services as well. We also implement perception and vision systems. And this is where we use some of the technology that we integrate within robotics. But it's more aimed at providing insights and analytics. It's specifically around counting, classifying, object tracking, and things like this. And then last but not least is consulting. And this is where we work with businesses to identify the opportunities, maybe some of the challenges, and working at how we can adopt this type of technology within their business's day-to-day line of work. So what I'm explaining on this slide here is how our business is structured, but in actual fact, this is how I believe the industry is structured altogether. So on the left-hand side of the slide, this is focused around the industrial robotic solutions that we develop. Now, these projects are mainly aimed to mitigate risk, improve safety, automate processes, and increase accuracy. And when we went back on the previous applications and the industries that I mentioned, these are these 4 key dot points that everyone is mainly interested in. When we move over to the right-hand side of the slide, we talk about inspection and monitoring. Now, this is very much focused to deliver data-driven insights. And we focus processes around inspection and data collection, data analysis, reporting, and data monitoring. And we use that with various sensors. So it's often enough where you find that both technologies both lines of business actually become integrated into one project. And this is what you can see through on this slide. So one of our priorities as a business is to provide scalable and adaptable solutions. So in order to achieve this, we needed to develop a flexible approach. So by doing this, we developed a layered approach. And this is what I was explaining in the previous slide when we integrate robotics and inspection methodologies on top of each other. So as you can see on the bottom tier, we look at the autonomous controls and hardware, and that's very much the robotics element. When we look at that gray area of the pyramid going upwards to the green, we're mainly looking at the inspection sensors and that connectivity approach, where we can therefore publish data, analyze it, and then report and integrate some type of artificial intelligence involved in this. So it's really important that when we adopt this methodology, this actually is what's been a real benefit to our success, because we're actually able to implement and develop things quite efficiently using this approach. So I'll dive into a couple of the projects now. So looking at the top is more of our robotic projects, and I won't go into too much detail on a lot of these because I want to get into the security portion of this presentation. But along the top, we've got our robotic applications. And I'll go into the next slide, which for the first one, but this is where we developed a robot to replace the rivets in the Sydney Harbour Bridge. The second one to the next is a current project where we're actually doing an upgrade, providing autonomy to an industrial slope mower. In the middle there, we've got a grade inspection robot, and that's a typical example of where I was talking about designing a physical robot to do inspection and monitoring. Next to that, we've got a robotic tomato harvesting gripper. We worked with a company to develop a customized gripper to be able to detect and harvest tomatoes. And the last one in that row is NASA clean room robots. And this is still ongoing, where we're looking at implementing various robots within NASA's clean rooms for environmental and personnel monitoring. When we look down below, these are a couple of our inspection and monitoring applications. On the left, we did another project with the Sydney Harbour Bridge guys, looking at track inspection for an anti-collision system. And we're also doing some current developments, doing banana defect inspections, where we can help optimize the packing lines out on some of our farms up north. So going into the first project that I was talking about, which is our Sydney Harbour Bridge robot. The Sydney Harbour Bridge robot was quite a necessary system to implement, as it was eliminating the need for humans to perform their work within confined spaces. Now, what we delivered as part of this project was a robotic inspection and maintenance system, highlighted in that bottom right image. We developed a custom robotic control app, which is the top image. And then we also developed and customized a human-machine interface, like a joystick controller, which attaches to a tablet. And altogether, that formulated a solution to replace the rivets, basically produce a robot to replace the rivets in the Sydney Harbour Bridge. So this is just a video showing the robot in operation. So what you're seeing along the top is the upper assembly, where all the advanced sensors are, such as the gripper, which clasps the new bolt that will be inserted. It also has a catchment, which you'll see in a few seconds. We've got a pan and tilt camera to provide that visual feedback and positioning. We also have laser positioning, so it helps the operator align, I guess, the tools to the specific rivet that they want to remove. And we've also got the capability, obviously, to drive forward and back along the confined space inside the bridge. So it is fully illuminated, as you can see, with LEDs. And this is what you're seeing with the tool change process, with that laser positioning, and then how we can insert a bolt where there's no bolt in that image, in that video there. Okay, moving on into some of our solutions. And I think you'll find this quite interesting, because this is where we start showing some of the autonomy in some of these robots. So our first solution is specifically tailored towards that left side of our business, which is that robotics aspect. And this is our industrial robotic mobile robot. And we're really proud about this robot because it is extremely modular by design. It comes with a control app, and it is fully autonomous. We've designed it in this way because we believe that this robot can actually be tailored rapidly for various industries and applications. It can, as it is highly modular, you can modify it, implementing different sensors, different payloads, and also you can control it through the control app in using different methodologies for mission planning. And this is what I'll explain to you here. So with mission planning, there are three key types of mission planning that we use and that is commonly used out in various industrial robots. So the first method is actually doing waypoint upload, and that's where the user specifies coordinates for a robot to navigate to and then to perform some type of task. The second option is actually what we call teaching. So you remote control the robot and you teach it to perform a particular routine or navigate along a specific path. And this is often some of the most desired methodologies to actually doing path planning, because you know exactly what you're going to get right from the beginning. And then moving to the third option, and this has been, I guess, quite favorable in terms of our robotic slope mower, where you key in a region of interest with exclusion zones, and the robot creates a predetermined path to then navigate along. And yeah, so we typically use this on like mapping tasks and I guess in our slope mower application. Alrighty, so this is now going into the, I guess, demonstrating the capabilities. Now in the top left corner, you can see obstacle avoidance. And you can see now the blue line as the obstacle is presented in front of the robot. It is trying to calculate a new path to get to its endpoint. So you can see that little yellow dot there. It's the robot's making its way there. Now, as we move across to the right video, we're actually demonstrating the robot's ability to publish its location and its position in an outdoor environment, and also publish its environment using LiDAR, the LiDAR sensor just on the right side of that top video. What's really interesting about where robotics have moved to, we're actually able to use really high accuracy outdoor positioning using what we call RTK systems. And that's giving us accuracies of up to about 3 centimeters outdoors. I'll talk about in the bottom course video, which I'll just replay. And this is what we talk about with autonomous mapping. So autonomous mapping is actually highly valuable in indoor environments. So it's important to teach the robot its environment before actually progressing on to mission planning, because it needs to know its environment and also provide the user a way to key in inputs, on certain areas where you want that robot to navigate to. And as we move into the bottom right video, we're looking at how obstacles are detected and I guess classified and segmented. So it's actually what it's doing in that video. It's perceiving obstacles. It's clustering those objects and saying, well, these are actually obstacles, and we want to work our way around that. Alrighty. So moving to the inspection side of the business, these are a couple of the service offerings that we provide. So in the first image, we talk about point cloud inspections, and this is using what we call LiDAR sensors, where we're actually able to replicate and digitize the environment around us by creating very high accuracy, what we call a 3D point cloud, basically. And we use this to detect physical changes in the environment. When we move to the next video, we're looking at something called photogrammetry, and it's using, I guess, a similar process where we're able to get a 3-dimensional model, but instead of using LiDAR, we're actually using high resolution photos, and we're using some clever algorithms to stitch that together into a mesh. Now, the difference between point cloud inspections and those textured 3D model inspections is that the accuracy is diminished, so you don't get as high a degree of accuracy, but you get the added value of having those textures that you get from those photorealistic images. And as we move across to the third point, which is thermal inspections, this might be something familiar across the security industry, where we use thermal cameras to pick up on heat signatures. Now, we've typically used this technology in the past to pick up defects, but I can see this technology is picking up heat signatures and looking for anomalies in the environment to alert in the security space. And last but not least, AI vision. This is also known as video analytics, also something that the security sector is probably quite familiar with, where we're able to pick up on various types of objects through classification. We can do counting and look for those anomalies and provide some type of reports and data insights. When we move into some point cloud processing tools, there are actually quite a wide variety of things that you can do using, I guess, point cloud. So after the robot has actually gone out to collect data, we can actually do some comparative analysis. So I actually see this as being something that could be done, performed in the security industry as well, which we'll touch on later on. But the first point is actually looking at point cloud change detection. So this is where we overlay 2 point cloud data sets, and we overlay the models over the top of each other, and we're simply just looking at deviations between the models. As we move into the center image, we're actually doing something called segmentation, clustering, and it's where we're grouping clusters of points, and we actually can not classified, but you can actually collect some valuable insights using segmentation, and we do this with a lot of automated robotic operations. And the third video is actually demonstrating the highest resolution that we can achieve with point cloud data, and this is where we can actually augment imagery, so visual imagery from a camera and LiDAR data, and you basically overlay those data sets together to get the output that you see in that right video. So as mentioned, what we brand as AI vision, also video analytics. We can do this. These are obviously some of the capabilities that are quite common in robotic applications. So on the left-hand side, what we're demonstrating is the ability to detect vehicles and number plates in real time, but also using sensors to also provide feedback on the distance of that vehicle to the camera. And this can be done in real time. There's a wide range of platforms and pre-trained data sets that we can make use of, and that's what you're looking at on the right video. So as you can see, there's a lot of we're able to pick up on various types of objects like vehicles, cars, horses, birds, and this is using existing pre-trained data models. And there's something that I should point out here as well, is you're not really restricted by the hardware in this space, because you can always do this type of operation as a post-operation rather than in real time as well. So it can be done offline. Alrighty, let's dive into the security side of things. So now that I've shared a bit about, I guess, and demonstrated the capabilities of robots, robots and inspection systems, I'm going to dive into the security space and provide some of these insights. So you know that there are solutions out there, and I've looked into them and I've got some feedback, but nonetheless, some have got some impressive features, but I'd like to see a little bit more out of them. So going from left to right, on the left you can see one of my favorite ones, which is Nightscope, and Nightscope is going to be featured in a few of our slides later on. But Nightscope has actually got some really impressive features. You can tell by its design, it's typically used for that indoor navigation because it's quite tall. It's got obstacle avoidance. It's got some clever features around picking up, identifying people, cars, and actually collecting some really valuable insights. But it does have that limitations because it's not really an all-terrain vehicle. When you move into the middle, these are your SMP robots. Now, these are more tailored towards that kind of, outdoor surveillance, application. Very similar features to Nightscope. But I think the difference comes down to what I call the user experience. So both robots will give you that user experience, like a custom app that you'll get with the robot. And I think Nightscope has done a little bit of a better job. And then moving over to the right image, it's been known for quite some time that obviously drones can do aerial surveillance. But what's actually come out in recent years is what we call drone in a box. Drone in a box is actually what is, I guess, that next tier to providing autonomy with drones. And it's where you can provide mission surveillance, where the robot can be scheduled to go off on a pre-trained mission, provide those video analytics, stream that data back to, to a cloud database where you can do those video analytics, and then come back to home base and then recharge for then to go off on another mission later on. So really interesting, and I see this as being a really good application in the security space. Okay, let's look at some of the limitations. And as I said, this robot's going to feature in our presentation today. So as you can see, this one is landed in a fountain in an indoor mall. So I guess what I want to take away from this slide is every robot has its limitations, as do we as humans, right? As we get older, we become a little more fragile. I know I have been in my recent years, especially being locked up in my home. But what's really important to pull away is that every robot is designed for a particular scenario and environment. And it's really important to look at, I guess, these key dot points, because terrain, indoor and outdoor challenges, the physical size of the robot, public interaction, speed limitations, and connectivity all provide challenges and restrict the robot to, I guess, their use cases and the environment they can be deployed in. But the last dot point is something that I'm really passionate about, and it's what I mentioned earlier in the presentation, where a lot of these robots are actually these these standalone solutions. So they're designed to just come out of the box and say, here you go, here's the app, here's the robot. Whereas what we do as an industry or as a business with our industries and our partners is we look at interfacing our solutions to other solutions. So we look at this concept called interoperability, where we look at interfacing with other commercial solutions and other industry solutions to provide further value and scalability. And that's something that you just don't see in these types of robotics, these existing solutions. So let's have a look at some of the potential applications where robots can provide value. Now, a few of you may be familiar with the deter, detect, delay, and respond security layered methodology. And I'm going to use, again, our Nightscope robot as a feature of this, because I think there are a lot of value that robots can deliver in these three key areas. So the first one we'll dive into, which is security patrolling. And these are very much what the current products are targeted towards. So we look at, obviously, the value here is we're looking at reducing the security labor force and also augmenting the capability of intruder alarm systems and CCTV systems. And I've put a little, I guess, a funny speech comment bubble around Nightscope there, saying that, you know, that car wasn't there before. And that's something that's really interesting that I think robots can provide. And it's when you have people out on, I guess, deployed out to do repetitive tasks, they're used to seeing the same things all the time. So they may not pick up on certain details, but when you build certain functionalities in a robot, they're always going to tell you the changes. So if that car wasn't there previously, it can provide that deviation as an alert or a response. Moving into the center, we're looking at routine perimeter inspections. And this is where I think LiDAR, the LiDAR sensors and that inspection methodology that I mentioned earlier will be very beneficial, because we're looking at detecting changes along, I guess, the perimeter in this use case. So something that's normally conducted by a human, you know, they might walk around, they say nothing's really changed, but there could be certain deviations that may not be picked up by, by fatigue or complacency, you know, that's been kind of developed through some of the employees that's been deployed on site. So we're hoping to, I guess, improve some accuracy in these types of systems. And last but not least is the response. So we really focus on deploying robots to provide that intrusion response and that situational awareness in these types of scenarios. And ultimately, the main value here is improving the safety and providing that, I guess, that presence, that remote presence in these scenarios. Okay, security robots the right way. So now that I've given you a little bit of an insight of what's out there in the market and some of the limitations and the applications, I want to give you, I guess, the tools that you need and the insights that you need to I guess, look at your projects, look at your, I guess, your upcoming problems in a new shade of light, and how you can potentially implement robotic technology on your next project. And I'm going to split this up into three key areas, and it's robotic design, robot connectivity, and then the data analysis and reporting. And it's really important to do this, and I'll explain as we go through. So the first step is robotic design. Now, on the left-hand side, you can see there's different types of robots. You know, you've got your legged robots, you've got your wheeled, your tracked robots, and you've also got your real nice flashy indoor robots in the top left corner. Now, all of these robots have advantages and disadvantages, and they all have their relative costs and value propositions. But I think what's really important is that, as I mentioned previously, in terms of their limitations, every robot is going to be designed to meet the environmental requirements. So we look at, is it going to be used indoors or outdoors? How often are the tasks going to be performed? That's going to really impact on the battery life. Can they be done via air or ground? Is proximity is proximity required to perform inspection, close-up inspections? terrain requirements, types of obstacles. These are all the things that we consider when designing a physical robot. Now, moving into robot connectivity. Now, when we talk about the existing robots that are the security robots that are on the market, they're actually looking at these three components on the left side of this graphic here, where you will get a nice robotic solution and you might get some modular payload. You'll get a robotic controller, and then you'll get some type of connectivity, whether it be Wi-Fi or 4G. And that's basically it with a lot of these off-the-shelf solutions. They package it up really nicely. They make it look really nice and schmick. But when it comes to developing industrial robots, there's a whole nother side that's often overlooked. And it's often when we talk about, recharging and docking stations, we talk about the post-processing around implementing some type of site hub, the security protocols, the firewalls. These are all really, really important. Even the dashboards and the alert system. So all of these things is what we look at as an industrial partner when deploying robots for specific applications and to meet industry requirements. So just going through a couple of the dot points, it's really important to look at, live data feedback, the types of the bandwidth that we're looking at, whether 4G is available in the area, or wireless networks like Wi-Fi, and the type of data sets that we want to be recording, because they also have requirements in terms of bandwidth. Step 3. This is really, really, an important step, which is often overlooked by most people, because a lot of people think that the robots are really, really clever. But step 3 is actually offloading this process, and it's actually happening away from the robot and often up in the cloud or on another system or another server. And I'm just going to explain this in a little bit of detail, but along the top, I've got a couple of scenarios that may be considered in the security space. So we look at people movement analytics, environmental comparisons, maybe suspicious package monitoring, security barrier inspections, or even facial recognition. These are all, analytics or software packages that may already exist, but it's not necessarily embedded within the robot itself. Right. So what's happening is, what we would say is, well, what information and data is required to perform these analytics and reporting, applications. And we say, okay, what sensors do we need to integrate within the robot? We'll upload that to the cloud. And as you can see here, this is our application in the left-hand corner doing what we call security barrier inspections. We're going to upload that point cloud to the data, that point cloud data to the cloud. And then we go through that process where we ingest the data, we analyze it, and we report it. And then we're going to spit out that information to be usable from by the user. And this is what you see at the end. So these current robots on the market, this is what they suck you in with. They have these off-the-shelf, interfaces which provide you all the analytics, but they are boxed in. But this is often enough the most important element of the 3-step process, because it actually provides the insights and it allows humans to interact with the robots, right? So it's providing those insights that's really important, and the fundamental goal. So when summarizing this, those 3-step processes, we understand that there is physical requirements that the robot will go out to perform the mission. The data will then be processed somewhere and then reported to a user. So when it comes to developing this, an industrial solution, we split it up into these 3 key areas. And that's really important to take away when, exploring robotics for your next projects. Okay. When making a decision to implement robots within your business or within a project, there are actually a few options. So purchasing is obviously, the first and foremost option, but something that's becoming really, valuable and advantageous is robots as a service. And it's what Shane mentioned earlier. And what this does is it transfers things, it translates things to an operational expense rather than a capital expense. And when you're trying to compare, an expense in terms of labor force, it becomes a really easy comparison to see where robots can provide value, because it is a little bit cheaper in that respect. We'll look at robots as a service first. There obviously are no or minimal upfront costs. You do look at fixed term contracts. And there's another way that you can also look at it as well as timeshare basis. So you can lease these robots based off a timeshare or fixed term leases. And one of the huge value points on this slide, or this option, is that the maintenance is no longer, the maintenance is, taken up by the OEM, right? So it's not of the responsibility of the security provider. So that's hugely beneficial to the person or the business that's providing the service. When you look at purchasing, I guess there's a little bit more risk that's put up front. So because it means that the onus is on the business that owns that robot. So you're looking at owning your own robots. You have to provide your own maintenance. So there are some things to consider there. But if you've got, a large set of applications and you do have that use case, it might be beneficial to have those robots there at hand, at your disposal. So the real question is you have to ask yourself, is a robot, or when is a robot the right choice for your application? And I'm not going to go into too much detail on the slide, but we as a business, when we do our consulting services, we break it down into these 4 key areas where we do an operational assessment where we look at the time and the frequency around the tasks. We look at the value, which focuses on the importance of the task at hand. And we also look at the costs. So how much is the robot versus how much is labor, and also that quality assessment. So we compare whether robots can provide further value in terms of quality and consistency. So I guess when we look at the outlook for security robots, I like to look at it, I'll start again. So when we look at the outlook in terms of security robots, my answer is pretty simple. It depends on 2 key factors. The first thing is going to rely on, the industry uptake. And the second thing is obviously the technology to support the development of the solutions. And I particularly am interested because I think as the industry takes up the technology and robotics as a whole, we'll start to see a lot more specific applications coming out. So, we mentioned before around the 4 key areas around deter, detect, delay, and response. I think robots are going to be able to actually deliver value, specific value, and specifically around providing more in the delay area that I didn't mention. When we move across to the bottom right image, interoperability, this is key in terms of industrial solutions, because what big enterprises want is they want to be able to scale their solutions across many of their sites, and being able to interact with and integrate with other enterprise solutions that they have within their business, specifically around their existing CCTV systems as well. And then if we look up along the top, as the industry uptakes robotic technology, we're going to find these automated processes, these processing pipelines be readily available. So where we can deploy off-the-shelf robots, and we can collect that data and then have those post-processing analytics come out and present it to you. So like I mentioned, that's a 3-step process. The robot doesn't necessarily have to provide the analytics on board. It's actually a parallel process. So I feel like as the security industry uptakes this information or this technology, we'll start to see more solutions around the software and to support robotic technology. So I think as a whole, this is my overall opinion. I'm happy to obviously answer any questions that come out of it.
Thanks very much, Dan. It's a real interesting insight into your background, and also how you think that your experiences will adapt into our industry. So we've got a number of quite thought out questions that have popped up in the chat box. I just wanted to start the Q&A session off, if you don't mind, just going back to your comment around the D3R model and how robots address almost all of those 4 requirements. But you did speak at the end there about the delay function, and I wondered whether you could provide a little bit more commentary around how you think robots might be able to assist in providing a delay to a an incoming security threat, when at the end of the day many organizations are paying for security guarding companies to provide those guards with guns at gates to intercept those threats in person. Can robots really do that?
I think at the end of the day, the answer is, I think the answer is yes, right? To put it simple. And the reason why I say the answer is yes is where there's in all of our applications and I guess projects, we look at where there's a need, we develop a solution. So as I mentioned on this slide here, when the industry uptakes the need for these solutions, the technology will rise to that occasion. So when we address that delay function, I don't think we're there yet, because there may not have I guess been a need for it in the first place. But if the industry is ready to take on, I guess, the development of a robot to provide that delay function, I think the tech is there to provide that, because we have got the right capabilities around object detection. We've got lights, we've got tracking ability. So the tech's there. It's just the need, right? It's that value. Really comes down to the value and that need basis, the industry uptake.
Great. I've got a question here from Taki from Power Generation. He made a comment around how robot movement and range could be restricted. He's saying that if a robot can't move beyond the company boundary, wouldn't CCTV cameras be a more economical solution? And he's asking for your thoughts on that.
Yeah, absolutely. First and foremost, even though I run a robotics company, my methodology is KISS. Keep it simple, stupid. If you can get away, if the premium solution is put CCTV footage, absolutely do that first. Robots are really going to be there if it's a necessity and providing value. So if you can't, if it's not feasible to, I guess, survey really large properties, really large areas, that's where they're going to provide value. But range, when we talk range, my first and foremost would be looking at, can you do it aerially? Like, can you do it from the sky? Because you can get range really quickly. If you need to get up and close and personal, maybe you might need to deploy the drone in a box solution or robot in a box solution and deploy these in various areas. But yeah, look, absolutely. I'd be the first option to say, look, assess where we can simplify the solution, use CCTV where possible.
Yeah, and that would be my advice to my clients as a consultant. Would be, if they're already able to get adequate performance out of a wired or a wireless CCTV system, then that's probably the way to go. But I can imagine that your kit could probably provide more situational awareness for those unusual circumstances that aren't covered by CCTV. So yeah, very good point. Bo from our chapter asked about the security of the data streaming between the robot back to the operator. So presumably, what sort of encryption of that transmitting data, and what would you recommend there?
Yeah, so I guess my expertise is probably kind of goes up to that point in time. So I guess that limit. So we focus all around on getting the data around the robots, but I can provide some insights. It is very flexible, right? So robots typically is an integration problem, right? So we're looking at existing solution, existing parts. So typically speaking, there's a computer on board the robot, and then there's some type of networking interface, right? So when you purchase a router, for example, you've already got firewall capabilities, you've already got VPN capabilities built into that. So we would therefore, work with an external party or a third party where we could integrate and understand their skills and their technical expertise in security protocols and that privacy I guess, portion of things. But I guess the simple answer to that is the sky's the limit, right? We specify the hardware, we interface the security protocols, and then the data is basically transmitted. So we integrate the 4G router or the Wi-Fi router. It could be internal networks, external networks, but we integrate the right hardware and the wrappers around that to meet the requirement.
I think I saw on one of your slides too, you talked about advanced encryption service as well. So, I mean,
Absolutely.
We would typically be using 256 encryption or something like that, but I guess it can be whatever it needs to be.
Absolutely.
Great. Chris Cubbage from My Security Meter gave a shout out to see that you're shining the night scope robot up in lights with it falling to its death in the pond. Michael Stark asked whether the presentation is shareable, and I did say to him directly that it's been recorded and we'll publish on our ASIS International ACT Chapter YouTube channel. Typically that's 24 hours after the event, so have a look out for that on YouTube tomorrow night. Chris Wright had a couple of questions. The first was for a drone in a box, is it possible to set height limitations and set routes such that it will reliably not stray into public airspace and our outside set perimeters? I guess that's an important requirement.
That is absolutely right. So we went back in one of my previous slides where we talked about mission planning. I'm just going to touch back in that. Here you go, mission planning. So just like a drone, you factor in your key parameters, right? So yes, altitude setting, limits. You can even do the pre-training. So if you want it to do a pre-trained route, absolutely. And that's particularly what they do in industry. So rather than the robot making up its own mind at an industry level, that middle option is often enough, the way that they go about it, because you want to make sure that you're going to get that right coverage. So, on day zero, when we're doing that commissioning process, it's often someone's, remote controlling and seeing what type of visibility they get out of the drone as they move around. And then once they're happy with the mission and the route, they basically save that. And then we say, we just want to repeat this on an hourly, 2 hourly, maybe daily basis. So absolutely, you can set those parameters.
Yep, great. And his second question was just an observation around much of the example tasks look like functions that can be done by CCTV. What is the special functionality that robots bring to a fixed installation? I guess that's something we already touched on.
Yeah, look, to be honest, I think just to put it simple, look, a robot is basically, the way the current robots are branded is they're mobile CCTV footage, CCTV platforms. Mm-hmm. So realistically, I'm just going to bring this slide up. Realistically, and this often is where we provide a lot of our insights, is where you've got large properties, right? We've got large properties, large areas, and it's just not justifiable to, put lots of sensors out there. So a particular application completely tangent to the, irrelevant to the security industry is on farms, right? There's a lot of farms are looking at IoT technology where they put lots of sensors, but when you talk about managing the assets, managing the sensors, managing the data, and also the cost to maintain those assets, it gets to a point where, having all of those assets, there's a trade-off with having just one mobile solution to go off on autonomous missions and collect that data, on a repetitive basis. So absolutely, like first point of call, like we do the assessment, are stationary or mobile CCTV, it's not mobile, portable CCTV platforms on those trailers, a viable implementation? If yes, go for that. If we're looking at those, larger areas, maybe drones are the solution in that case. So that's where we've really got to look at that value analysis that I pointed out towards the end of the presentation.
Sure. And Taki came back again and made another observation around gathering and analysing information is one part of security, but he's also interested in the development of the response part to, I guess, the D3R model. In many incidents, the security personnel can be easily outnumbered by the adversary. Usually, they can come in big numbers. Any development on how robots could help our limited security personnel out there to hold their ground until help arrives, or maybe even back them up against multiple adversaries. And I guess this is where some, drone swarm technology could come into the picture.
I like that, Shane. That's nice.
Yeah.
You're looking for a robot job?
I'm learning. I'm learning quick.
No, exactly right. Look, yeah, look, I think it all comes, okay, this is going to come down to that value analysis, right? So when we talk about backups, right? So is it a viable solution to have a bunch of robots sitting in a storage shed ready to come out on D-Day? Maybe not.
Yeah.
But the capabilities are there, right? So like if an intrusion alert happens and your security system say there's been a breach at this location, and it provides a picture of a person or a bunch of people. You deploy a bunch of drones to that location and you're tracking them, you're providing that type of thing. So yes, you can, but it's that value analysis.
I guess the real answer is how much money has the client got to spend? If you want to pay for an army of robots to to stand by in the shed in case something happens, then go for it. But what you're saying is that technology's there. They can operate in unison, and they can provide a backup function to manned personnel response.
Absolutely. It always comes down to a need, Shane. Like at the end of the day, if there's a need for it, then someone's going to develop the tech for it.
Cool. Chris Cubbage came back again, and he mentioned that he was interested in the business models. Nightscope has taken some time to develop their business and still struggles with its business case. And then he's also asking about your approach with the Sydney Harbour Bridge robot. He's asking a question about whether they bought or are they leasing that. I'm not sure whether you can go into detail there, but anything you can share?
Yeah. So look, I can talk from I guess an overarching point of view. So and I'll answer a couple of things. So the first thing is our business approach. So as a business that's focused on industry partnerships, and I guess, industry partnerships, we're focused on delivering solutions that are, or delivering solutions that solve problems that come from industry. So when you look at a lot of, current robotic businesses, they develop a solution and they go out to just sell their product. So for example, Nightscope or SMP Robotics, they've developed their robot and they're going out to lots of security companies, say, here, we're going to buy this robot, or lease it as a service. And that's fine, and that's their particular model. I'll be honest, the way we operate, we're more of we work with industry partners. So where a business in a particular industry says, hey, we have this problem, we know that there is a demand for it, there is a problem that we're trying to solve, we need a solution for it, and we think robotics may provide that solution. So what we do is we basically work with them to say, we do an analysis, we do some feasibility work, that's the consultant side of the business. And what we actually do is we use our intellectual property to accelerate development. And at the end of the development, the overall product can be owned by the partner company, because if they want to develop and they want to sell that because there's a need in there, and they could probably do that a lot better than what we can, because at the end of the day, we're the tech guys, right? So we understand how to harness the technology and deliver the solutions.
Mm-hmm.
But realistically, they sell that better than what we can. So it's really important. That's how we differentiate ourselves to a lot of other businesses, and it's actually been really beneficial. So in regards to the Sydney Harbour Bridge, that was a custom built solution, and it was built and bought. So they own that solution because it's going to be used over the long term. Sometimes from our perspective, it's not quite feasible to take on those risks because, if the project was canned, then, we don't get paid basically. Yeah. So these are, I guess, the types of models that we consider when moving forward.
Good question. David Brindle asks about regulations. So aside from flying drones, where CASA regulates that quite heavily, is there any guidance or regulations in New South Wales around operating automated robots in public spaces?
It's really, that's a really good question, actually. The answer is no. So a lot of the limitations just comes around risk assessments around the body, right, who wants to implement it. So we've got some experience on construction sites, mines, in the farms. Farms are way less, stringent. But typically around construction sites and mines, it's adhering to their regulations, right? So it's just going through the right risk management protocols. Public spaces, interesting one. It's just getting approvals. At the end of the day, if you've partnered up with the right bodies and we find bringing them into the development process gets them quite excited. So I can't talk too much, but we have got a project where we do need to liaise with government bodies to get approvals for things. And our strategy with that is actually bringing them in as part of the development process, which allows them to kind of help us make decisions and how we can deploy. So when it comes to getting those certifications and approvals, it's much easier to get those, get them checked off pretty quickly.
And Conrad from Industry Risks is asking about what application that you've applied your technology to so far. What where is it best used to it effect? So I guess where's your technology best used at the moment, and what application is that?
Yep. So if I just quickly just make reference to one of the earlier slides, I'm just going to quickly go down to the pyramid. I'm going to keep going. So okay, our technology is basically applied realistically in the blue, orange, and grey area, right? So what's really important to know is at the application level, we look at mobility, right? Autonomous mobility. We look at data inspection and collection, and sometimes we look at providing some type of autonomous process, okay, or autonomous task, right? So it's less inspection, more so, it could be pick and place or something like that. So
right.
At the hardware level, it's very much into either developing custom hardware if it doesn't exist, and that's the specific side of things, so specific development. But our current tech is more so around that orange layer and that grey layer. So where we interface our control logic, our control systems, and I guess the backbone of most robotic systems. And then what that means is effectively we can go off and develop things, those specific applications a lot quicker. So yeah, it comes into kind of like the hidden gems that's not quite on the surface. But the AGV that we have on that we showed in the presentation, that's a purely inspection vehicle. So we strap on different cameras, different LiDAR sensors, and we can do some of those analysis, like change detection with LiDAR sensors.
Cool. Mark Jarrett wants to know what weapons can be mounted to your robot, mostly to enlist them into assisting in repelling an armed attack. Now, we actually talked about this when we went through your presentation. You had an idea of drones with pellet guns, and I talked about a previous experience where a client wanted to know whether they could mount machine guns to PTZ cameras. So what's your advice there? Is it a good idea or not?
Look, I'll definitely say I'd steer away from that. I mean, I'd leave that to the defense guys. Look, you open up a can of worms. At the end of the day, you're relying on a robot to make decisions. I'm right now in this day and age, and even moving forward, I think robots, there's always going to be a two-level response, right? So a two-tiered response where robots are going to be, that first engagement, that first kind of response, but they're never going to pull that trigger. They can't, right? They just absolutely can't. So you're going to have that operator. So you might have someone, and it's actually being done in Sweden with some of autonomous buses and trucks. So you'll have an operator sitting from a control center, and he's actually managing about 9 to 10 different trucks. Just looking at it from a visibility point of view, you can see cameras, some feedback, but there's still an operator there. So so the answer is no, it's not there yet. And are we going there? Probably not.
I think it was a joke question to start with, but it was a very serious response. So thank you for that.
I think it's quite a legitimate question, actually. And if we're not looking at lethal force, perhaps we could consider something less dreadful, like launching taser electrodes to immobilize them until a response force can attend.
Look, I think you're definitely going to get accuracy out of that. With target detect, we've seen what vision systems can do. You're going to get highly precise target detection. So if you do want to deploy those types of things, absolutely. I wouldn't be surprised. I honestly wouldn't be surprised if defense have actually worked on this type of tech.
No
doubt. The black ops type of projects, so they don't really talk about it too much. But look, the scary reality is the tech is there. If the funding is there and the need is there, the chances are people have developed it. So the amount of times where we actually, get engaged by a business to say we want to develop this, after about a day's worth of research, we find other businesses that have tried to solve similar problems over in Europe and America. And it's just a matter of, taking that and dissecting and being like, well, why didn't it work? And what are the takeaways that we can make that industrial rather than being just a research project? Cool.
Andreas Malianto asks, on average, how much does it cost per robot per hour? Presumably that's a robot as a service business model. He's asking for a friend to compare quickly when the time is right cost-wise to consider replacing some of the guards.
I don't have the right insights to that. I don't really have the tangible, the actual costs. But what I can say, I wouldn't be surprised if it's about 50%, right? That's just my experience of what I've seen out in the market.
50% of an hourly rate of a security guard.
Yeah. The reason why is it's the interesting thing is when we look at evaluating robots as a service, it's not actually how much it costs to deploy the system. It's actually what can we define as I guess a feasible cost to charge for it to be enticing to be taken upon by industry, and that's really where it's going to come down to. So as the demand comes up, and you can see supply and demand, right? As the supply is there, costs go down. So I can't really provide tangible and quantifiable metrics, but it's around 50%.
That's all right, Dan. We won't hold you to it. James Jordan just followed up regarding the CASA legislation comment that he was just saying that there's also a requirement for anything with a camera would be subject to state territory privacy and telecommunication legislation. So and that makes sense.
Absolutely.
Raj asks about whether there's any denial strategies or possibilities to explore in this area. So I guess that's on the deny side of the D3R model, and I would think that there is, and that's probably where robots are already quite well suited. Don't know whether you have any other comments on that.
I'll be honest, I'm not too familiar on the deny side. Again, it really comes down to the need and the application. Whether there's a need, someone will develop the specific tech around for that application. Yep.
Chris Cubbage is railroading this conversation here. He's asking all members whether should someone consider consulting on a security robot project, would they require a security license of some form? Just asking to be annoying. I mean, that's a fair comment.
What was that? Sorry, you just cut out there, Shane.
It's to do with licensing and whether advice or services associated with the provision of a security robot solution would constitute the requirement in states or territories to require a license? That's probably something for us to answer rather than yourself.
Yeah, that's definitely an interesting one. Yeah, absolutely.
Yeah, because like in most of the states and territories in Australia, there is a requirement for providers of security services, whether it's consulting, whether it's guards, whether it's locksmithing services or installation services of CCTV equipment to be licensed. And so it's a fair comment. You would have to assume that there probably would be a requirement for that at some point. I suspect that the legislation is probably a bit murky in that space and probably needs to be tidied up moving forward. But you might be the test case, Dan. You never know. We might have to go to the security ombudsman and ask him the question.
That would be nice. It'd be nice, definitely.
So any other questions here? Mark Binder has asked about how do you overcome robots as a service / security as a service hesitancy with potential clients? Are you experiencing in your industries the same as what we're experiencing here, where most of our clients are fairly traditional in their approach? So they like to pitch for CapEx each year with the bosses, and they get a fixed amount of money, and then they just spend it. They spend it throughout the 12 months on whatever they need to do for that 12-month program. But the as a service model sort of throws that all up in the air, and you've got to get your funding through other OpEx measures. Are you seeing any particular views expressed from your clients on that front?
Yeah, so I do have some insights in that area. So I can talk, I guess, from an agricultural standpoint, because I think robots as a service is actually taken off in that space. So where we look at robots are in these types of I guess scenarios, they're performing a service that is normally performed by a human, right? So in these types of applications, they're actually augmenting the capability that they normally have, but just reducing their labor force. So instead of employing 10 people to do a job, you might be able to get away with 5, right? So I think that's looking at I guess a farm, an agricultural application where we talk harvesting or weed spraying. It becomes a very easy decision where they say, oh, yep, no worries, just bring the robots down. We're going to lease them for the next couple of weeks. The pushback's not so much there because it's almost like a direct comparison. As long as the robots can provide an accurate solution or service that's equivalent to that of a human or better, the uptake is there. But when it comes to, I guess the CapEx side of things in the robotic space, a lot more people are resistant in that space because it is relatively a high expense, specifically because whilst you might be able to buy a robot that is 80% there, it's not 100%, right? And that extra 20% still requires some significant development, and that's what's often overlooked. So it often, the CapEx side of things and the purchase up front is actually the pushback, not so much the operational side.
Right, interesting. He also asks about who owns the outcome data that you generate. That's a really good question on intellectual property.
Yeah, no, that's great. Okay, so something that's we do with a lot of our clients is we're not really interested in owning the data. In some applications we are. So in the inspection monitoring solutions, where we're very much interested in doing that top part of the pyramid, which is that AI, we do consult with them and say, look, to further the success of this, we want to be able to do AI monitoring, and we need large data sets to train. But in any of our robotic applications, we have our intellectual property, which is like I explained, the building blocks. So if we collect data, we develop a customized robot in collaboration. It can be owned by the client at the end of the day. But I think also touching on that as well, a lot of the existing solutions, and I'm pretty sure Nightscope and S&P, because they have their boxed in solutions, they're actually getting all their analytics and their data. So whilst you might have access to it, they also have access to it. So that's really interesting as well from a security point of view.
Yeah, who actually owns the IP at the end of the day, or at least who has carriage of it?
Exactly. I think, and I think it's really important. Like, we are moving towards I guess a world where AI is going to drive a lot of insights and a lot of value. And it is very much going to be a customized thing. So if we don't have the data, we can't develop the AI. It's simple as that. So I think realistically, businesses do want to progress, beyond into the next 5 to 10 years. They need the data sets. So it's if you want the value to deliver in your day-to-day business, you're going to have to cough up and share that data somehow to get that value.
Yep. Chris Cubbage made a final comment there. He said that the Nightscope robot in the US is about $6.50 per hour to operate for clients. So, that's pretty cheap. But then again, it is limited. By comparison, security guards in Australia, probably the cheapest ones are low $30 an hour AUD. So it's not far off from what you said, 50% of that. But it is a little bit cheaper again. But then again, it falls into ponds. So what do you do?
I'd look at that. I'd be really interested, because I think the $6.50 an hour sounds extremely cheap, but it's what
US.
But it's what they lock you into, right? So
yes,
that's something that I've been really I've always kept an eye out for. So even though they say it's super cheap, how often are you doing those services, and how long are they locking you in for those contracts?
You're definitely going to pay, or get what you pay for too. So you can imagine it's not a very sophisticated offering.
Yeah.
Exactly. Yeah. Great. We're almost at the end of the questions. I just had one last one to finish off on, something that we didn't really talk about too much, Dan, but wheels or legs? What's your preference?
Okay. I'm going to touch. I'll bring the slide up for you. I think it will provide some nice context. I like wheels or tracks. Where is it? Okay. Personally, I like wheels or tracks, mainly because when we look at industrial applications, often enough you don't want to deploy and purchase a robot that's 50 grand, 60 grand, and for it to only last half an hour. You want to be able to get longevity out of long life, to perform operations consecutively. So when we consider a daily shift that could be 12 hours or 10 hours, or even 8 hours or 6, whatever the application is, those legged robots, they'll be lucky to give you an hour. They're highly versatile. They can go upstairs, they can do all these types of things, and that's what really sucks a lot of people in. What's really interesting is the things that you see on top of Spot the Dog, which is the legged robot. They're actually just bolt-ons. They're not really well integrated within the robot's perception. So it's like I've got a perception system, and I need to actually put an additional battery on that, because you can't actually plug it into Spot's battery. So they're not like I said, they're boxed in like Apple. Whereas when you look at tracked vehicles, you get bigger batteries, you get real chunky drives. You're not chewing through a lot of power. Staying there. You don't need to hold itself up like a legged robot is. So yeah, I'm very much around the wheels and tracks.
Great. Well, it makes a lot of sense, I suppose, and I can definitely see the applications there that wheels and tracks do provide. So it looks like you can get away with those in almost all applications. All right. Well, I think we'll leave it there. Thanks so much, Dan, for lending your time tonight and chipping in your industry advice in the robotics space, and how you think that might assist the security industry moving forward. I think the next 5 years will be very exciting, and we're starting to see some movement there. So if anyone's interested in following up conversations with Daniel, the last page does have his contact details. You'll be able to find him on LinkedIn, and you can also email him directly. He has quite an impressive website that I was perusing earlier as well. But I think, Daniel, you're welcome to speak one-on-one with people if they're interested after tonight's presentation.
Yeah, absolutely. If you got any more questions, feel free to contact me via email or even reach out through LinkedIn. I'm quite active on there. But yeah, once lockdown permits and the rules are alleviated, more than happy to tee up coffee catch-ups if you're local. And yeah, I guess at the end of the day, if you are interested in seeing how you can integrate robotics, we are happy to help. At the end of the day, our core goal is to enable the adoption of robotics and robotic tech within various industries. So it's only going to be possible through professionals like yourselves. So more than happy to provide my insights and get the ball rolling.
Great. Thanks so much for your time, Dan, and I hope that everyone else found the session insightful. As I mentioned before, the presentation has been recorded and we will publish that on our ACES ACT chapter YouTube channel tomorrow. And if you'd like to be kept informed of other similar webinars and in-person events when permitting, join us on our LinkedIn page. We're quite active on LinkedIn and would love to see you at the next session. So thanks a lot, everyone, and have a great evening.
Thanks, Shane. Thank you very much.